Okay, while the last video was uploading, I reread example 2, part D, and realized it said when will its speed be 20 meters per second. I was thinking it was asking what would our speed be after 20 seconds, so ignore this. All right, and so it wants to know when. It wants to know delta t. And it says 20 meters per second, but hang on a sec. I'm only throwing it up with the speed of 5 meters per second. And as it goes up, it slows down, it slows down, it slows down. It's never going to get to 5 meters per second on its way up. And as it comes back down, it speeds up, speeds up, speeds up. And when it gets back to my hand, which is really part E, its speed's going to be 5 meters per second in the other direction, down. And this was up. So when is it going to be 20 meters per second? I'd have to be standing like on a roof and throw it up over the edge of the roof, and it will only be later after it goes further past where I threw it from that it would be 20. I think I really wanted this to be 2. When will it be 2 meters per second? So how long has passed when the VF is 2 meters per second? The VI, and we're assuming upward, it could be downward, and the VI is 5 meters per second up, and the A is 9.81 meters per second squared down. So then you would do A equals VF minus VI over delta T. So delta T equals VF minus VI over A. So VF would be 2 meters per second minus 5 meters per second divided by negative 9.81 meters per second squared. Okay, and when you do this, you get a delta T of 0.3058 seconds. Now you could do it assuming that we meant, okay, you're going to throw the object up over the edge of the building, and then at some point down here before it strikes the ground, it's going to be going a speed of 20 meters per second down. It will never go 20 meters per second up. It'll never reach that speed. It'll stop first. So you could do that, and if you did, then using this equation, it would be delta T is equal to VF minus VI over A. The VF would be negative 20 meters per second because it's going down, minus 5 meters per second. That was going up, so it goes in as a positive, divided by negative, my pen's dying, 9.81, so it'll be negative 25 divided by negative 9.81, which will be a positive, and you'll have a time of 2.5484 seconds. Okay, so my apologies. I think I wanted it to be 2, but if I wanted it to be 20, you would do this, but it would have to be going down. It will never reach a speed of 20 meters per second upward if I only threw it at 5 to start with. Okay? And I think I answered the last part. What will its speed be when it goes back to your hand? Exactly what it was when you threw it. So if you threw it up at 5 meters per second, it will come back to your hand at 5 meters per second, just downward, because our world is symmetrical. All right, let's do example 3. I'll leave 4 for in class, I think, but example 3. A hot air balloon is rising at a speed of 30 meters per second, which is a pretty good clip. So here it is. So the balloon speed is 30 meters per second, and a person falls out of it when the balloon is 500 meters in the air. So this person who, last time you looked, they were hanging over the side waving, but then they do a header out. If the balloon is going up at a speed of 30 meters per second, then it means the person's initial velocity must also be 30 meters per second up because they were in the balloon. So the instant they fall out, they're still moving upward 30 meters per second. But then gravity will come into play and will begin to pull them down and slow them down. And it says the balloon is 500 meters in the air, which means the person has 500 meters to fall. So it'll be 500 meters down. With what speed does the person hit the ground? Oh, this is not going to be pretty. Or It is going to be painful. So you're looking for VF. You have VIA and delta D. So VF squared equals VI squared, plus 2A delta D. We have ups and downs, so make sure you're calling up positive, down negative. So it'll be 30 meters per second squared plus 2 times negative 9.81 meters per second squared times negative 500 meters. VF squared equals, this will be 900 meters squared per second squared. 2 times 500 is 1,000. So this will be plus 9810 meters squared per second squared. So you'll end up with 10710 maybe. Take the square root 103.49 meters per second. Ouch. That's going to be like way too, like multiplied by 3.6. Oof. That's going to be over 370 kilometers per hour. Don't fall out of this airplane or balloon, okay? How long before the person hits the ground? So I would use for part B, A equals VF minus VI over delta T. I would not use delta D is equal to VI delta T plus 1/2 A delta T squared. Because you're looking for T and you have a T squared term and a T term, this would end up giving you a quadratic, which if you like the quadratic and want to practice it, you could use, but I'd go this route, it's a lot easier. Rearrange for time. Time is equal to VF minus VI over A. So time is equal to VF we just found, 103.49 meters per second. VI was, and it is going to be down. So it needs to go in as a negative, because when we take the square root down here, you get 2 options, but Buddy's definitely going down. Okay, so it goes in as a negative, and VI was 30 meters per second up, and A was negative 9.81 meters per second squared. So you get 133.49 divided by 9.81, and you get 13.607 seconds. Ooh, I still have 2.5 minutes. Maybe we will start number 4. The same hot air balloon is rising at a speed of 25 meters per second. So now VI is 25 meters per second up. If the object which falls out of the basket takes 8 seconds to touch the ground, delta T is 8 seconds, how high was the balloon when it fell? Okay, so you have your balloon here and the Buddy who's falling out of it. So Buddy's going to go down and the balloon is going to go up. So, but you're looking for how high was the balloon, when the guy fell. So you're looking just for how far he fell. I was thinking it was asking how high was the balloon when he hit the ground. Again, A is 9.81 meters per second squared. Delta D is equal to VI delta T 1/2 A delta T squared. So delta D is equal to 25 meters per second up, so it goes in as a positive, 8 seconds plus 1/2 negative 9.81 meters per second squared times 8 seconds squared. Delta D equals, first term is 200 meters minus second term is 313.92. So you end up with a negative 113.92 meters. Why negative? Because he's falling down. This means that you end up 113.92 meters below where you started. So end up below where you started. So it tells you that the balloon is 113.92 meters from the ground when you first fell. Okay? And so we would then say 113.92 meters down. All right? So now for the night of the test, you're going to have questions with these. So tonight, for now, it's to get ready for the test, but then After you write the test, you'll have homework on free fall, okay?